Hello everyone. In the last video we had discussed about germ layers, that is the ectoderm, endoderm and the mesoderm. In this video we are going to discuss about how these germ layers are forming from single zygote, that is a single cell. So the germ layers is a pretty complex structure, and how is it forming from a single cell? This is discussed under embryology, and embryology is a vast subject which includes a lot of other things, and we are just gonna deal with this specific area of embryology to clear our concepts. Now first of all, what happens is that the gametes, that is the male gamete and the female gamete, fuse in any organism and form the zygote. Okay, so zygote formed here is covered by a layer called the zona pellucida, which is present from the egg cell, and this zona pellucida will gradually disintegrate, and this zona pellucida restricts the size of the zygote as it divides. So the zygote cannot increase in its size, so the cells inside the zona pellucida start to reduce in size. Okay, so the next stage over here is the morula. The word morula comes from mulberry. So mulberry looks same as that, pretty much same as that of morula, so the people thought to name it as name the words also like same, so they called it morula. It is a 16 to 32 cell stage, and all the cells over here are undifferentiated cells, therefore all the cells are alike. Then we have the blastula stage. This process from morula to blastula is called blastulation. Here the first layer of cells differentiate, so we get the first outer layer of trophoblast cells. These trophoblast cells are responsible for forming the placenta in any organism. So the placenta helps in nourishing the growing embryo and is very important structure for its growth. Alright, now in this blastula we see that these cells start coming closer to each other in a process called compaction, and they move towards one side, leaving a cavity over here which contains a fluid, and this cavity is called the blastocele. This cavity will develop and later form the yolk sac in any embryo. Okay, and it will store the nutrients, as we know. And this outer layer is called the trophoblast layer of cells, and this inner cell mass is called the inner cell mass because it is inside the trophoblast layer of cells and it is a mass of undifferentiated cells. Now this inner cell mass is very useful in stem cell therapy, and this inner cell mass is very pluripotent, so it can develop into anything, and this inner cell mass is only going to develop into our embryo. Okay, so this inner cell mass, we will focus on it. Now the next stage, we can see over here in this stage that the zona pellucida is starting to disintegrate, so I have removed parts of it to indicate that, and in the next stage the zona pellucida will be completely gone, so the structure can expand to its full size, so the cells can gain the cytoplasm. Okay, so the structure will be quite big structure, you can see over here. So here we can see the main events are that there is another cavity which is forming over here. This cavity is known as the amniotic cavity. So this amniotic cavity contains the amniotic fluid, which will be later in this amniotic fluid only the embryo will be floating upon. This, you can see there is a considerable change in the inner cell mass also. The inner cell mass over here in the blastula stage was all compact in one point, but here the inner cell mass has formed this cavity, and also this bilaminar disc over here, you can see bilaminar disc, which comprises of two layers, as the name suggests, bilaminar, two layers, which is epiblast cell layers and hypoblast cell layers. Epi means above, so epiblast cell layer is the layer above over here, and the hypoblast cell layer is the layer below. The epiblast cell layers can be more 2 to 3 cell layer thick. I have only shown one cell layer, but the hypoblast cell layer is just one cell layer thick at the bottom. Alright, so Let us see what happens over here. The trophoblast cells will further divide into syncytiotrophoblasts cells and cytotrophoblast cells, which is not the in the context of this video. We will discuss about how the germ layers are formed, and for that we need to focus on this portion of the structure or the growing embryo. That is, this portion is called the bilaminar disc. Okay, so let us see. We can have two views of the bilaminar disc. One is from this side, as you are seeing. So I have put this view also over here. This whole view is this view which we are seeing, and another view is that if we see from the top side, as we know, this is a cross section of a sphere. So if we cut a sphere in any plane, we will get a circular cross section. So this we have cut laterally. Okay, so this is the plane through which we have cut the sphere. Okay, so the sphere has something above it and something below it, and now we are going to cut the sphere through this plane and watch it through this plane. If I'm able to give you the idea, so this will be also a circle. Okay, and we are watching that circular cross section, so it will look something like this. Okay, so over here you can see only one layer of cells, because that is the topmost layer of the cells. The other layers of the cells are below it. Alright, so what will happen now is that a primitive streak will start developing over here. What I mean by a primitive streak? Primitive streak means that the cells on one side will start shifting a little bit towards that side, and the cells on the other side will start shifting a little bit towards that side which they are in. For example, let us take this line. The cells on this side of this line, the left side of this line, will start shifting towards left a little bit, and the cells on the right side of this line will start shifting a little bit towards the right, creating a furrow over here. This furrow will show us, if we see through this furrow, we will be able to see the lower layer or the bottom layer of cells also. So that type of furrow will start developing at this edge, and then it will grow and grow till the middle. This furrow distinguishes two sides of the embryo, which is the upper cranial half of the embryo. Alright, so this is the cranial half, this is the cranial half, cranial. Okay, so let me write with my cranial part. Okay, and this part which does not have the primitive streak is called the caudal end or the caudal part. Caudal meaning tail or the below part, anyways. So this is the caudal part. Cranial refers to the head part, and the caudal refers to the tail part. So this distinguishes these two parts of the embryo. Also it distinguishes the left and right sides of the embryo. As you can see, this part is the left side, this part is the right side. So that's enough of that. Anyways, we are not discussing about that in this video. Now what will happen from this primitive streak is that cells will start migrating towards the bottom layers. This is happening because the epiblast cell layer is dividing very rapidly, and therefore there is room for less space. There is not much room for cells over here, therefore the cells will start migrating. So some cells will end up in between these two layers of cells, that is the epiblast layer and the hypoblast layer of cells, and some cells will end up replacing the cells of the hypoblast layer. So let's say we are indicating the cells which are migrating from the epiblast cell layer as red color. So we will find something like this roughly drawn diagram, which will give you the general idea. That is, these red cells over here, this mass of cells have ended up between the layers, the epiblast layer and the hypoblast layer of cells, and these cells over here, you can see these cells are replacing the hypoblast cells. So the structure is starting to bend a little bit because of the unequal growth of the hypoblast and the epiblast cells. Epiblast cells are growing very actively and very fast. Therefore, the epiblast cell layer is starting to bend, and also we are having this accumulation of the cells which are migrating from the epiblast. As this will continue, we will get the structure as we see in the germ layers diagram. So this epiblast layer, outer epiblast layer, will form the ectoderm. Then we have the mesoderm, which will be formed by these cells which have migrated it between the layers, and then we will have the endoderm formed by those cells which have replaced the hypoblast layer. So as this process will continue, all the cells in the hypoblast will get replaced. Okay, so you can see over here all the cells are in red because all the cells are going to be replaced by the migrating cells, and therefore we call this a definitive endoderm. Over here the hypoblast layer is also an endoderm. If the migration in some lower animals like in porifera, sponges and coelentrates, this migration does not happen as efficiently. So this endoderm contains the cells of the hypoblast as well. Okay, and sometimes the migration does not happen only, so therefore we do have no mesoderm over here. And if the migration is proper, we get a different, means the cells are the same, but the cells come from the epiblast layer for this endoderm, and this is called the definitive endoderm. Alright, so that's how we get the three germ layers, that is the ectoderm, mesoderm and the endoderm. Hope you liked the video. Hope you got some good knowledge from this video. Okay, if you like the video, please like, comment and subscribe. See you in the next video. Bye.